Assalamualaikum and a very good day. This video is going to show you the simulation result from the AVR simulator for our project. Basically, the project consists of 5 tasks. Task 1 is to initialize the ports to be connected to the interrupt switches, the parallel LEDs, and the 4-digit 7-segment display panel. Task 2 is displaying the alternate display pattern as shown here. Continuously using the parallel LEDs with 100 millisecond delay between the change. Task 3 to display the last 4 digits of our matrix number, which are 0109, 0215 and 0239 on the 4-digit 7-segment display panel. Task 4 is displaying the Night Rider display pattern as shown here, with 100 millisecond delay between the LEDs changes. When interrupt 0 INT0 is triggered by falling edge signal. And lastly, task 5 displaying 0 until F at the rightmost 7-segment display panel when interrupt 1 INT1 is triggered by rising edge signal. Let's look into the coding in the Atmel Studio. Here in our coding, we start by declaring CPU's frequency to 1 MHz and declaring all the library header used. In our project, we only use input-output, interrupt, and delay library. Next, we declare function prototypes for all our sub-functions: init port, blink LED, delay timer, and display matrix no. After that, we declare the interrupt service routine ISR for both INT0 and INT1. In the ISR of INT0, we do the coding for task 4. Meanwhile, in the ISR of INT1, we do the coding for task 5. Next, we declare all our subfunctions one by one. Init port subfunction will do task 1. In this subfunction, port A is initialized as 7-segment display controllers. It will determine which of the 4-digit 7-segment display will turn on. Port B and port C will act as the output that connected to LEDs panel and 7-segment display panel respectively. Pin D2 and pin D3 at port D is initialized as interrupt switches for INT0 and INT1 respectively. Blink LED will do task 2 and display matrix no will do task 3. Delay timer is to generate 100 millisecond delay using CTC mode. To do so, first we set WGM12 and CS11 to set the mode to CTC mode with prescaler equal to 8. Next, we initialize OCR1A to value of 12499 and the TCNT1 with value of 0. When this TCNT1 reaches the value of OCR1A, which is 12499, the OCF1A flag will be set. The timer will be stopped, TCCR1B equals to 0, and the TCNT1 is cleared by setting OCF1A equals to 1. Finally, we move to the last part of our coding, the main function. We start our main function by calling init port subfunction to initialize all the ports used. Then, we set GICR equals to 0xC0 to enable the INT0 and INT1. Next, we set MCUCR equals to 0x0E. Since we need the INT0 to be triggered by falling edge signal and the INT1 to be triggered by rising edge signal. After that, we enable global interrupt by writing SEI bracket in our code and calling display matrix no to do task 3. Finally, we use while one loop to continuously do task 2 by calling function blink LED repeatedly. Let's look how our coding looks like in the AVR simulator. Before we start the simulation, we initialize each component to their respective port. Port A at here as the selector of 7-segment display panel, port B at the parallel LEDs panel, and port C at 4-digit 7-segment display panel. These two pins are pin D2 and pin D3 as the interrupt switches. So we start our simulation. The simulation starts with task 3 to display our matrix number at 7-segment display. The 7 segment is displaying 0109, 0215, 0239. Then it moves to task 2. These LEDs will keep displaying this pattern as long as no interrupt been triggered. When int0 or int1 is triggered, task 2 will be paused for a while to allow the interrupt and continues its operation when interrupt finish. Let's see what happens if we turn off pin D2. Here, task 4 will be executed as the pin D2 receives falling edge signal and trigger interrupt 0. The parallel LEDs display the night rider pattern. Then the operation continues with task 2. What happens if we turn off pin D3? INT1 is not triggered. This is because INT1 needs rising edge signal for it to be triggered, meaning it needs the switch to be changed from off to on, rising edge. So let's turn on back the pin D3. Now the INT1 is triggered as it receives rising edge signal. The rightmost 7-segment display panel will display 0 until F. Then the operation continues with task 2. Task 2 will be executed continuously non-stop except when external interrupt is triggered.